Hi everyone. We will be waiting 2 to 3 minutes before we get started to accommodate for the rest of the attendees who are in the middle of connecting. Okay, welcome everyone. I'm Heike Ritter and I will be your host today. Thanks for joining and thanks for being part of our community. A few reminders before we start. This webinar is being recorded and will be shared publicly. The recording will be posted on our community at aka.ms/security-webinars. During the webinar, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking the Ask a Question button. Questions you post will be made publicly available or visible, and if you prefer, you can post your questions anonymously by checking the box right below where you enter it. We often get many questions during these webinars, and we are doing our best to respond to all of them in real time. If the answer was not provided or if you have additional questions afterwards, please don't hesitate to ask them on the Microsoft Threat Protection Forum at aka.ms/mtptc. If you're listening to this after the fact as a recording, you can also use this place to ask questions. We love to hear your feedback on how we can improve these webinars, so please do that at aka.ms/security-webinar-feedback. This is important so we can deliver the content you need. If you haven't already, please join our community at aka.ms/security-community. That's the best way to ensure you don't miss any future webinars or major announcement. In our community, you can speak directly to our engineering teams that are building our security products. For Microsoft Threat Protection, you can do that at aka.ms/mtptc. We believe that the best way to improve our products is by removing any barriers between you and the people that create them, so please join. So today we are back with Tracking the Adversary. It's the third episode out of 4. Michael Malone, a principal program manager within our customer experience team in Microsoft Threat Protection, will continue with another slight less hands-on webinar. And without further ado, I'll turn it over to you.
Awesome.
Michael.
Thank you, Heike. So welcome back for episode 3, summarizing, pivoting, and visualizing data. So this episode is going to be all about how to turn a large amount of data into a consumable row or two, so that you can actually act on it and visualize it for presentation or helping your analysis. So for a short recap, so this is the third episode of 4 in the series. Our first one we went over is KQL fundamentals, essentially the basic operators and some of the core tables inside of Microsoft Threat Protection. And our second episode last week was on join. So all different ways you can use join, filter, and union information. So if you haven't had a chance to view those, I recommend checking them out. We're going to assume that you have an understanding of these topics as we go into our third episode. So without further ado, let me switch my pane here to my query window. Okay. So to get started, probably one of the most common operators of this type that you're going to use is going to be summarize. So summarize is going to turn a table, so a tabular data set. So if you remember, that's where you have columns and rows essentially. And it's going to consume that and perform a calculation. And typically you're just going to be returning a single row or optionally a set of rows grouped by a column that you specify. So for example, let's take this little query here. So email attachment info. So if you remember, email attachment info is going to have one row for each attachment we have that was processed by Office ATP. We're going to run the summarize operator on it, and we're going to get a count based on the senders from address. So in other words, we're going to see how many attachments each of these individual senders have sent through Office ATP. So by hitting run query, and as a note, as a reminder, remember we are dealing with a time-based system here. So this is going to be within the last 30 days. So you can also specify different time frames up here in the upper right. So what you're going to get back is we group this output by the senders from address. So you'll see we have the Office 365 reports address, sent 20 total attachments, and postmaster at mtpdemos.net sent 21 total attachments. So whatever you put on the right-hand side of this by statement is going to be your grouping mechanism. And whatever you have on the left over here is going to be your calculations you want to perform on that data. So let's say you want more than one calculation. So you can actually specify, more than one grouping mechanism in here. So you can specify more than one column to group by. So we have, in this case, let's take the email events. So this is going to be whenever we have an email processed by Office ATP. And we're going to get back the count of emails that were processed based on the senders from address and the recipient's email address. And then we're going to go ahead and just grab the top 100 of these by the number of emails in descending order. So what we'll get back from this is essentially, we're going to be looking at the count of times that we saw Azure no reply send an email to SecOps, and there was a total of 46 emails sent. So by specifying a second column over here, we essentially are going to be breaking down the way that we summarize and calculate based on both of these columns. You can think of it sort of like grabbing a distinct and then calculating where those distinct rows matched. Now you'll also notice I renamed the column here from the default, which is going to be count underscore, to emails by using emails equals count. So this is handy if you want to keep track of what the actual column is. There is always a predictable name that comes back, but sometimes if you're going to use this and then join it with another data set, you want to make it easy for somebody to understand what they're looking at. In this case, we're using emails to represent that count. So for our SQL people out there, it looks something like this. So select top 100, sender from address, and recipient email address, and then emails, which is equal to count of splat. Actually, this should, from that data set. So from email events, and then group by sender from address, recipient email address, and ordering by emails in descending order. So that's essentially the SQL equivalent for if you're a SQL person. Now, there's a whole bunch of different operators inside that you can use with summarize. We're going to talk about a subset, but I would definitely recommend checking out the official documentation for KQL to see the full list of what's available. So we're going to use the min and the max operator. And as you might expect, min and max are going to give you the minimum and the maximum value from the column you specify. So here, we're going to take alert evidence. So if you remember, alert evidence is going to have one row for each individual entity that we found associated with an alert. So it's a one-to-many ratio with alerts. So there's alert info, which is going to have the actual row for the alert itself. And then you can have potentially multiple rows of alert evidence that ties back to that specific alert info using the alert ID. So in this case, what we're going to look for is whenever we have alert evidence where the account name is not empty. So we're going to make sure that it has an account name in it. And we're going to go figure out the earliest timestamp and the latest timestamp that we saw that a given account name associated with an alert evidence row. We're also going to bring back the count of entities that we saw associated with that given account name. We're going to sort that by the count in descending order. So by running this, what we're going to get back is going to be sort of an interesting view. It's going to show you based on the alerts that you have in this in the system, basically in this case the last 30 days. The first time and last time we saw a user account associated with an alert, and then the number of times was listed as alert evidence. Once again, for our SQL people who are out there, it looks something like this. So you have select earliest is equal to min timestamp, latest is equal to max timestamp, and the count by the account name. So in other words, we're going to be using a group by account name and then ordering it by the count descending. And as I mentioned, so we're using an is not empty, which is essentially the same thing as this where clause here. So we're going to say where the account name is like percent. In other words, we're checking for an empty string. So let's get a little bit more advanced. So since Defender, ATP, and MTP and all of our systems are essentially a time-based system, sometimes you want to bucket this time into groups of a specified size. So to do that, we can use an operator called bin. So bin is going to take a date time field, in this case we're going to use timestamp, and group it by a specified interval, in this case 1 day. So this is going to be from midnight until a second before midnight that day, and you'll be able to block your measurements like that. So we're going to use the identity logon events, which, if you remember, comes from Azure ATP. That's going to be whenever you have essentially a logon activity that occurs, where we have an account UPN populated, and we're going to count the number of logons that we saw by that account UPN on a daily basis. Now, there's another operator that's kind of hiding down here towards the bottom. I've got render time chart. So the render operator is what enables you to automatically create a graph. Now, you don't have to use render. You actually can select it after the fact. I'll show you how to do that. So by running this command, we're able to look at 30 days worth of data. And we're looking at how many times we saw each individual account UPN associated with an identity logon event. Total count, and then we plot it along a line chart. These line charts are super handy. As you can see, you can mouse over and get the value from any individual day. And you've got our key down here at the bottom. You can see what specific accounts are there. Now, let's say you didn't want to use the render operator. You can also click on chart type and specify what type of chart you would like to pick. In this case, we got bar charts, or you can actually go back to the original table itself. So if you want to see what this looked like before we applied the time chart to it, what you'll see is we've got a user here, pe.krebs@mtpdemos.net, and you'll see we have a timestamp of 7/24/2020. We saw on that day 102 different logons for that user. MTP Global Reader is represented multiple times here because we've got the 7/25 date, we've got the 7/11 date, we've got the 7/27 date. So each day we've got a different block of time because of the bin operator. So let's go ahead and get a little more advanced here. We're going to use this bin data again. So in this query, we're going to take the identity logon events and once again filter out. We want to make sure we have an account UPN present. We're going to get the number of logons by account UPN on a daily basis. But then we're going to perform another summarize on it. So in this case, let's say we wanted to figure out what the normal activity looks like for that user. So now we can run another summarize to figure out what's the total number of logons done by a given account UPN based on that daily basis. We can also figure out what's the average number of logons for each of these UPNs the minimum and the maximum on a daily basis within that time frame. So this is kind of a cool capability. It lets you see exactly what normal looks like for that account and what its overall volume is. And in this case, we use a different type of chart. So we used a column chart here. So column chart is going to project it along different columns that you can see grouped together by the user principal name. Down here at the bottom, you're going to see the individual column names, so most logons a day and fewest logons in a day. And if you wanted it back to your table format, what you'll see is for each of these UPNs, we've got the actual raw values available. So, excuse me. So another common situation you'll find yourself in is where you want to find the latest row based on a given timestamp. So if you remember, KQL or Custo, the underlying language there, is a time-based system. So in most systems, you're going to constantly just append new rows rather than deleting and modifying. That's where you're able to get a lot of that performance from when it comes to querying. We can trust that the row hasn't changed. So there's an operator you can use called argmax. So what argmax is going to do is it's going to look for the maximum value of whatever you put as this first parameter and return whatever you specify in the second and then on parameters into this operator. And we're going to group this by device ID. So in this case, if you remember, device info has partial check-ins and full check-ins. So we're going to look for only full check-ins. And the way we're going to do that is going to check for the OS platform to not be empty. And then we're going to go ahead and get the latest information from that. So let's run this query. Now, for each device ID, because we're using argmax, we're only going to get a single row back with every single column from that row. So we're not actually maximizing each individual row here. It's really worth noting that. We're grabbing the latest timestamp for that given device ID. So these two get paired together. Now, if you only, for example, wanted the OS platform, you can actually just put OS platform in here, and it'll give you back just that one row instead. So consider your use case and how you plan on using it. But as you can see now, all the other rows have been stripped out, and we only brought back OS platform. So if you don't need all those additional rows, that's a trick you can use to reduce that. Now, this is great and all, but it doesn't really give us a, let's say we wanted to see what devices had those specific OSs, the actual device names, and we wanted that represented by OS. We didn't want to necessarily have one row per device. We want to count, for example, of how many devices had that OS. So to do that, we're going to go ahead and use a new operator here called makeSet. So makeSet is going to turn the row into a JSON set. And once again, we're going to do this by OS platform. So here we're going to have device info, get it where the OS platform's not empty, get the latest row based on timestamp returning all the columns by device ID. And then we're going to go ahead and get the count of devices that had a given OS, as well as a list. So device list, as you can see here, is now a JSON formatted list. So this might be a handy way for you to actually produce a list of things that meet that specific summarization you're doing. Now, I want to also talk briefly about the decount operator. So the decount operator is going to give you a count of distinct entities. So for example, if we just wanted to know how many devices were in there, how many distinct devices were out there by OS platform, we can just run decount and pass it device ID. So in this case, it's going to break it down by OS platform and give us the count of distinct rows that we got back based on the device ID. So this is going to give us a summarization, but there's a very important thing to note when using decount. So decount after a certain threshold is going to perform an estimation. What that means is if you start getting thousands, tens of thousands, or hundreds of thousands of rows back, it's going to start guessing essentially about how many distinct entities in it from a performance perspective. Now, there is actually a way to increase the accuracy. You can specify an integer parameter here. So as you can see, I put (4) at the end. And this is going to increase the accuracy of the decount function. So this is a way to increase the accuracy, but again, it is still not guaranteed to be 100% accurate from a distinct perspective. This is a very accurate estimation. You won't really actually see errors at these small numbers like 17, 2, and 3. When you get into the thousands and tens of thousands, where you start to see a little bit of skew and fluctuation. If you want that perfect accuracy, the best way to do it is to use the distinct and then pair that together with a count. This should always return you an accurate count of distinct device IDs in this case by OS platform. So keep that one in mind. If you're trying to do a highly accurate count, something that needs to be maybe published to leadership or something, consider using distinct paired with count. If you're trying to get a pretty darn good number of how many times you've seen a file written inside the enterprise, Decount's going to be your friend, especially from a performance perspective. So let's talk about series. So a series is essentially a calculation performed on a periodic basis. So it's sort of like a summarization with a bin, except in this case, each of the rows is going to have a calculation, even if it's 0, plotted on that periodic basis. So what we've done here is we've taken email events. So when we have an email pass through Office ATP, and we've made a series that counts the number of emails based on the timestamp for the past 30 days. So from ago 30 days can give us 30 days from today. And then now is sort of a shortcut to get the current date time. And we're going to step it on a daily basis. As a note, this can be 1 day, 1 hour, 1 minute. There's a whole bunch of, 1 hour, 1 minute, for example. But this is going to give you that frequency at which you're checking the this particular value. And we're going to group this together using the sender from domain. So in this case, you can see for each individual domain that's out there, the number of emails that pass through Office ATP on that given day. So we have to correlate the count with the timestamp to really get a value out of this. Now, for human analysis, this isn't all that terribly helpful, but this is extremely beneficial when you want to do something like anomaly detection, because you have to have a representative sample, including when there's nothing there, to determine what normal and abnormal is. Now, I have to warn you, we've got some geek stuff ahead. So this is where we put on our beanies and start getting to calculating. So we're going to do some anomaly detection here. So once again, we're going to run our mail count is going to be equal to the count of emails based on the timestamp on a daily basis on the sender from domain. And we're going to pass this into a function called series decompose anomalies. Now, this is available in all Custo language. This is actually a Custo language capability. So it's technically available in Sentinel and all the other Microsoft products as well, or if you have an Azure Data Explorer cluster. So what we did is we passed in the value mail count. So this is our value we're going to look for anomalies in. And we get back 3 columns. Now, this is a shortcut I use to name these flag, score, and baseline, because if you don't pass this in, you get these unbelievably long names that end in flag, score, and baseline. It's going to be, I think, series decompose anomalies flag, series decompose anomalies score for mail count. It's typically a very long name. So this is sort of a shortcut I use. I'm using the extend operator to add columns, and the columns are going to be flag, score, and baseline. And it'll take the first, second, and third column that comes back from series decompose anomalies and name them flag, score, and baseline. So what we're looking at here, the first one is flag. So flag is going to be -1, 0, or 1 every time. 0 means it matches what we would expect to be at that particular timestamp for that particular domain. 1 means we saw an abnormal increase in activity relative to what normal looks like for that domain. -1 means we saw a decrease, a sudden decrease in activity for that particular domain. So this is a great way to see if you see a sudden spike or a sudden trough in activity. The second one we've got here is the score. So the score is going to tell you how anomalous it is. So it doesn't go positive and negative like the flag. It's going to give you a measurement of how strange that particular activity is. The higher the number, the more strange it is. The third one is the baseline. So the baseline is going to be what value it would have expected at that given point. Now, another kind of a cool capability here with series decompose anomalies is it's actually aware of what's called seasonality. So for example, if you think of a lot of the things you might trend for volume, you're probably going to have more activity on Monday through Friday if it's a lot of companies. Your typical 9 to 5 perhaps. So series decomposed anomalies will actually predict what the seasonality looks like and apply that. So if there's always no operations every 5th day or 6th day, it'll expect no operations. So the anomaly is actually based on the data set, which is kind of cool. So let's go now. The thing is when we get here, we have a slight issue. So we want to be able to look for a spike. Let's say we want to look for sudden jumps in traffic. But what we have is essentially an array field here. This is a set. So we need to actually analyze each row. So to do that, there's an operator you can use called mvexpand. Now what mvexpand is going to do is it's going to create one row for each value in the field that you're expanding and replicate that row over and over and over again. Now, again, we're looking at 30 days worth of data stepped on day, right? So what this means is we're going to have 30 times the rows come back than we had before, because we're taking each of those individual flags and we're multiplying it by the number of rows. So we should see a couple of ones floating around in here. Essentially, it replicates the same row over and over again and puts one value for each of these flags. So now that we have this flag here, we can use a where clause from if you remember from our first episode to filter out only where the flag is equal to 1. So now let's say we don't care about what normal looks like. We don't care about all the zeros. We only really care about the spikes. We actually don't care about the troughs. So we're going to go ahead and run the same query where that flag is equal to 1. Now, there's an important slight change I made here in this query. So when you use a tool like a query operator like mvexpand to work with something that's an array field like this, you need to tell it what type of data it's going to become. Because if you think of how JSON works, everything is essentially text inside JSON. We don't necessarily know it's an integer for sure unless we tell it it's an integer. So I added a piece here to say mvexpand flag to type of integer. So this is going to make sure that the flag column is integer. It'll work without it, but it's going to come back as a type called a dynamic. And a dynamic is essentially like a JSON type field. There's a lot of really great stuff you can do with dynamics, but if you want to do things like filtering accurately, I highly recommend explicitly specifying the type when you're doing your expand operations. And the last thing we did again is we reordered the flag, score, and baseline so it's nice and easy to read. So let's go ahead and use this. So this query here, we're going to go ahead and set the interval to every 12 hours. So we're going to take the email events. And actually, that doesn't look like a very good example here in this case. So we have email events. We're going to be looking at the number of emails that were sent per sender from domain based on timestamp on a daily basis on a 12-hour basis over the past 30 days. Let's go ahead and switch this one up here. Let's go ahead and see if we can try a different interval. Let's do maybe by hourly and see if that looks like a better graph. Yeah, it's not playing with me today, of course. So what we're looking at here is we're going to be looking for the anomalies, and then once again looking only for the spikes, and then going back in and expanding out the scores to a type of a double. So a double is essentially a floating point field. We're going to then use summarize to get the max score. So let me go ahead and jump back here, and I'll run just this section here. I'll set this one up. In fact, let's go ahead and one day. Try that one out, see if we can get a better looking graph out of this one. So what you're going to see is we're now going to grab the maximum score. So if you remember, the score is how anomalous it is. It's not necessarily that it's anomalous. That's told by our flag. So our flag being 1 means it's a spike. We're now grabbing the maximum score from that data set, so the highest value by the from domain. And then we're going to go ahead and grab the top 5 of those based on score. In fact, let's go ahead and grab the top 15, see if we can get a better looking one out of this. Now, from our last one, so from our last option, our last episode we were discussing a right semi-join. So what this means is I only want data from the right side where this particular key matches. So we're going to take the email events table again, and we're going to filter those to only where we have an email event here, a sender from domain that matches up with an email event. And then we're going to count the number of times we saw an individual email from a sender from domain on that same interval we specified before and turn it into a time chart. Let's see if this one gives us a better looking graph. I added a few more rows in there. There we go. Okay. So as this is a lab domain, there's spikes that'll appear periodically. It looks kind of weird. It'll be more interesting when you take a look at it inside your enterprise where you actually have some normal looking data flow. But what we have here is we grab the top 15 rows based on how anomalous the data was relative to its normal behavior, where that row was essentially a spike. So we can see we've got a bit of a spike here. I did grab the top 15 this time, so unfortunately it looks like we did get some pretty normal looking data out here. There's a little that might be classified as a spike in this lab environment. Now, there's a bug in this data, this query here. So the real data geeks out there, if anybody picked it up. So what I did is I grabbed the maximum calculation where we had a spike, but I expanded out the score. Now the score would also technically include a trough, because if you remember when we look here, when I do this filter, I'm not getting the score that corresponds to that spike. I'm getting every score. So if suddenly that email dropped off the face of the earth, and let's say we had thousands of emails, and suddenly it went down to 5 or 100 or some abnormal drop, I was still using MD-expand to get back our score. So the score that came back is not necessarily associated with the flag. So let me show you how to use a dynamic in this way. So once again, same stuff as before. This time we're going to use an option with MD-expand called with item index. Now, what with item index is going to do is it's going to bring you back a column that's going to tell you which item it is in that particular list. So when we expand it out, we can say this was the first or the second or the third or the fourth item in flag. So once we know that, we can go back in and say, now I only want the spike score where it's associated with the same the same interval as the spike was detected. So this will help us get rid of our trough. So if we take a look over here to the right, scrolling, you'll see there's a flag index over here, 0, 1, 2, 3, 4, 5. So this is what enables us to correlate that flag with the actual spike. Now I'm going back in here and I'm going to use where flag is equal to 1. And then I'm going to use extend to add a column. So instead of going ahead and just MD-expanding out the spike score again, what I'm doing is I'm going to go ahead and grab the index of the score field that matches where the flag was. And I'm going to tell it it's a double. So I'm going to just basically tell it, make this a floating point value, if you will, and add that as a column called spike score. Once again, we can do max score by that. Max score is going to be the maximum of that spike score by the account's UPN, and grab us the top 5 and turn it into a time chart. So this time, there we go. This time, we're going to join it back again on the identity logon events on the account's UPN, and we're going to go ahead and basically identify anomalous logons. So in this case, you can clearly see that this is a very anomalous logon activity we've got here. So we've got a bunch of nothing, and all of a sudden we've got 66 out of nowhere for pekrebs at mtpdemo.net. So I bet you if we did top 1, this should probably give us just that one row back. So as you can see, actually there's a spike right there. Matt at MTP Demos in this case looks like he suddenly logged on 12 times, where normally he's logging on 1, 1, 1, 4, 1. So as you can see, it's picking up what the most anomalous data is within that data set, and then we're going to go back again and use our right semi-join on the identity logon events, grabbing the account logon data for that particular user, and then giving us the count again on that same interval. That's how we get this chart at the bottom. Good to go. So that's what I have from a summarizing, pivoting, and visualizing data perspective. Tali, do we have any questions in the chat today?
Yes. A question about how you can search for a particular hash of file name in email security alert.
Okay. So if we're looking for, let me bring this up here. Bring this back. So are we talking about alert evidence in this case, like an alert associated with an email? Or are we talking about searching for an attachment that has a given hash?
Let's start with an attachment.
All right. So for attachment, we're going to be using email attachment info. And this, if you take a look again, so we've got our schema over here on the left. If you click on this little expander, you'll see we have a SHA-256 field that's out here. So this would be a great example where you do where SHA-256 is equal to, and then the SHA-256 of the file that you're looking for. There's also, if you're looking for an alert associated with a hash, so let's say perhaps it didn't fire an alert for whatever reason. Maybe it's not actually malicious. Maybe you're looking for data exfiltration or something that happened using a legitimate user or something. That would be how you would search for it that way. If it is something suspicious or maybe associated with an alert, so alert evidence would be where you would go. So if you take alert evidence, I would recommend using SHA-256 if possible. So we can do where SHA-256 is equal to whichever one you're looking for, or you can also look for SHA-1 if you would like as well. And as a note, going back to our first episode, there's also a really cool capability where you can use search, and you can specify SHA-256 is equal to whatever you're looking for, and this is going to search for that for any row in any table anywhere where that SHA-256 came up. So this could be a file that was written. This could be an email that had an attachment, or the email itself. Anywhere we see that SHA-256 field.
Thank you, Michael. Can you give more recommendations on how you can extract valuable information on emails using the summarize operator? For example, how you can count different emails from a specific sender? Absolutely.
So if you're looking for, email events, if you remember, is going to contain essentially any time an email passes through Office ATP. So we can do email events. And once again, we're going to come up use the summarize operator. So there's a bunch of different operators you can use here. So count, decount, you can see min, max. There's actually percentile, standard deviation, sums, all kinds of different calculations. So let's say we wanted to track down the number of different. Let's start out with sender from address. In fact, let's summarize the count by sender from address. And we'll do recipient. So email. Let's see. We'll do the recipient email address. So this is sort of what we did before. So if we have so the first one we'll do is we'll look at calculating the number of individual emails are sent between two people within the last 30 days. Now, let's say we wanted to also get information whenever there was an attachment associated with it. So what we can do in this case, we can use our join operator, and we can join the email attachment info on so this is the network message ID. So this is sort of a good indicator this is a good key that you can join these two tables together on. And actually, let's get a little fancy. Let's do let's keep it simple for the first one. So if you remember right, we're gonna go ahead and deduplicate our email events table based on network message ID. So in this case, let's go ahead and do a kind equals inner. This case is essentially going to remove any rows that were in email events that did not have an attachment associated. So in this case, we've got an attachment account. We can also switch it up and do a left outer. And from here, we can do the network message ID, and we can do so this would be the total emails now. Actually, hang on, that would be. I do have to do a couple of. I apologize, I didn't quite have this one quite ready for demo. We can do. Let's go ahead and grab email attachment info. We're going to do a summarize, because it's possible to have multiple attachments in a single email. So what we'll do is we'll do summarize argmax. We'll make it even easier. Let's do distinct network message ID, and we'll do. Actually, apologize. I was not ready for this particular demo here. See, so if we just do distinct network message ID, on network message ID. So this will basically give us back where we have if there's an attachment or not. So we have a total count, which will be total is equal to count, and then we can go into here on the right, and then attachments, add attachments. So I'm going to show you a new operator here called Countdiff. So Countdiff will do a calculation only when a given condition matches. So what we can do is not empty. And we can do network message ID 1. Okay. So what this will do here, if you remember when we do a join, by default, we're going to have both of these keys here, right? So it's going to have network message ID twice. The first one, called network message ID, is going to come from email events. That's our left table. On the right table, I'm basically taking wherever we have an attachment and giving back just the distinct network message ID. This gets rid of the possibility if you have multiple individual attachments on a single email. In this case, we just want to see where the email had an attachment. And then we're going to join it together on the network message ID, which will make the network message ID from email attachment info network message ID 1. So the first one we did here is a total volume of email between sender and recipient. And then whether it has an attachment is determined if that network message ID 1 is empty. So in this case, because it's an outer join in this case, we're going to get empty rows back whenever the email did not have an attachment. And this will give us an idea of how many emails they sent, how many attachments. And if you want, we can even get into all the way into what specific attachments were sent by just joining these together.
Michael, I can give you another advice on that. You went with the complex solution. If you were scrolled down at the left in email events, you will see we actually have a column that tells you how many attachments or URLs are inside the table. Yeah.
That's actually so that's actually an even easier way to do it. I actually did not. So I actually learned something on that one. I did not know about the attachment count field. So there's actually an easier way that you can figure out for if there's an attachment on there. Now there is a couple of other really good things you can do here. Unfortunately, this demo environment's not really suited for it. But we can do email events. I can do so summarize. Countdiff is not empty. And in this case, what we can do, so we can take, there's a couple of features in here. So fish filter verdict and malware detection, malware filter verdict. So we can see if there was phishing emails or malware emails sent from a given domain. So let's say fish count is equal to, in this case, we'll do the fish filter verdict. And our second one here, we're going to do malware count is equal to Countdiff is not empty. Filter verdict by sender from domain. So in this case, what we'll do, let's see. I don't know if we're going to actually have any malware fish in here. Oh, looks like we do have a few. I have to look at this, validate my data on this one. We should, because typically with email events, if we do take 100, oh, that's why, because we have, and then we'll do a count in here. So total emails is equal to count. And I have to check my logic on that. I apologize. My demo did not work in this case. So
you can just take a sample, project those fields, and we'll look at it together. Today, it will have fish or malware when it is recognized as fish or malware. Otherwise, it might have a different value. So not all the time. Sometimes it has a different thing.
Good to go. Let's just double check ourselves in this one here. I may be mixing it up with the other. Let's see. Ah, that's right, because it's not fish. Yep. Thank you. So in this case, kind of fish. So in this case, we would be doing not equal to not fish. Good call on that one. That's the reason. So it's a little bit different with the attachments. The attachments are blank or they contain information. So in this case, we'll do malware filter verdict. All right, give this one a run. Of course, I'm getting bit by the demo gods now. I apologize for that. So
connected to the email events. It's not connected to a table.
That's okay. Thank you. I was wondering why my highlight wasn't working. There we go. That's the demo gods. There we go. Okay, this is what I was expecting to get back. Apologize for the couple of bugs there, but you know, it happens to everybody. So in this case, we can now break down all the individual emails that were sent, the total count of how many emails were sent. In this case, 16 of the 275 came back for some reason as phishing from Microsoft.com. That could be from lab testing, for example. And then let's see if we have any. I don't think we have anything with malware picked up in here. No, not in this particular case here. But it's an example of how you can actually identify and measure the volume of phishing or malware and total emails for a given sender domain. So another kind of interesting capability. And so I'm going to use that as an opportunity to segue. So remember, we do have another episode coming next week. So next week is going to be the completion of the series, where we're going to dig into performing an actual incident hunt using almost exclusively advanced hunting. We're also going to be going through a bunch of cool features that you can use with advanced hunting that are not necessarily always in the query pane. We're talking about the Go Hunt capability, a few other options that you have when you're investigating your incident. Let's say, for example, from the alerts view. So looking forward to everybody joining in next week. And let me go ahead and switch my sharing here to the slide deck.
Thank you so far. Before we close out, some reminders. We have some more webinars scheduled. So as Michael mentioned, we have the last episode coming next week where you apply all your knowledge now and you go hunt. And then a few Azure Sentinel webinars as well. One is about threat hunting and reduce the dwell time with Azure Sentinel, threat intelligence automation with Risk IQ, and Log Forwarder deep dive. And then the other one that is also scheduled so far is optimizing Azure Sentinel KQL query performance. And all the details and the registration, you go to aka.ms/security webinars as usual. Again, if we missed an answer, I don't believe so. I think Tali did a great job. But if you have additional questions, please go to our forum, Microsoft Threat Protection Forum at aka.ms/mtptc. And with that, thank you so much, Michael, for yet another demo-only presentation, and also Tali for helping and for answering all the questions. And yeah, I'm looking forward to the final episode next week. Thanks, everyone who helped to make this happen, and have a good day or good night. Goodbye.